A cylinder fit with a piston. Kita highlight dulu. A cylinder fitted with a piston contains 5 liters of gas at pressure of 4 atm. The entire apparatus is immersed in a water bath to maintain in a constant temperature 25 degrees Celsius. The piston is released and the gas is expanded until the pressure inside the cylinder equals to the atmosphere outside, which is 1 atm. Assume the gas behavior and calculate the amount of work done by the gas as it expands at constant temperature. So, that means this is V, this is P1, this is isothermal process at 25 degrees Celsius. T equals, this means that this is the reversible process, which is 1 atm. This is P2, and then this question we calculate the amount of work done. So what is work done? Okay, so first, the things that you must do is write all the information given. Okay, V is 5 liter, P1 is 4 atm, P2 1 atm, and T is 25 degrees Celsius. You must convert this equation in unit Kelvin. So we must plus with 273.15 Kelvin equals to 298.15 Kelvin. And this equation, once we calculate the amount of work done. So what is the work done? And then write the gas constant. So first thing first, you must write the general equation for reversible process, because this equation is reversible process. So write the general equation, which is dW equals to negative P dV, and then derive this equation, integrate both sides because we want W, right? So integrate both sides, and then we get W equals to negative integrate P dV. We have 2P, so we can use this P. So write the ideal gas for P. So P equals to nRT over V. And then substitute this equation in P. So we get W equals to negative integrate nRT over V dV. nRT is constant, so move to the front. And then we get W equals to negative nRT integrate dV over V. When we integrate this, we get W equals to negative nRT ln P1 over P2. Why we use this equation? Because we have P1 and P2. We only have V. We don't have V1 and V2. So we use this formula. And then the n number of mole for this, we must calculate number of mole first. So the number of mole we can get from the ideal gas equation, which is N equals to PV equals to RT. substitute P, substitute V, substitute R, substitute T. Then we get 4 times 5 divided by 0.082 times 298.15, and then we get the number of mole is 0.818, and then substitute this number of mole in this equation, and then we get negative 0. This is number of mole, this is the gas constant, this is the temperature, and ln P1 and P2. And then we get, after calculate, we get the answer, which is 2811 joule. This is the answer. I hope you guys can understand what I have there.